Now let me formally introduce you to the definition of principal components. It says that among all possible lines which are passing through the center of data, it is the direction on which if we draw perpendicular lines from all data points, the variance of projection points are where it is cutting the line, the variance of projection points and the line Z will be maximum. So if you think of, you can put line like this, you can put line like this, you can put line like this. It is that particular line where the variance of the projection points is going to be the maximum. If you think of, this is what you actually did when you found the red dashed line, the direction where the data points had maximum variance. And the sum of square of perpendicular distance from this line Z1 will be minimum. This is also bound to happen. Think of why. Let me explain you why it is happening. If you think, let's just focus on one particular point, because if you understand one, you can understand anything. So if you think of one data point, and if this is x1 dimension and this is y1 dimension, you can say that the total distance d1 square is equal to x1 square plus x2 y1 square. Now if you think of, let's say that z1 direction is like this, then the variance, as we know, the variance is quite huge in the z1 direction. Now if you take a look, z1 square plus z2 square again makes a triangle, and by the method of Pythagoras theorem, z1 square plus z2 square has to be equal to d1 square. Now obviously if z1 square is bigger, then z2 square has to be smaller. Why? Because the sum is fixed, right? So if the variance is too much in the direction of z1, which means that the distance from center are huge, then obviously the perpendicular distance has to be smaller. And if you think of, in this case, in two-dimensional case, if z1 is the first principal component, z2 is the residual, the second principal component. So if you think of, what did you do? You redistributed the total variance in such a way that the first principal component has maximum variance, and the first principal component, if you think of, can be thought of as the linear combination of x and y variable. The second principal component has the residual variance. If you think of x1 square plus x2 square, x1 square plus y1 square has to be equal to z1 square plus z2 square, because the distance is same in both the cases. So x1 square plus y1 square has to be equal to z1 square and z2 square. The only difference is that z1 square is much bigger than x1 square or y1 square, and that's why z2 square is much smaller. So what did you do? You redistributed the total variance in such a way that this variance is much more than this variance. Second principal component obviously had the residual variance. Now I will explain you the 3D case of principal components.